In this video, I'll show you how to tackle complex Boolean cutouts on curved surfaces. We'll start with the base mesh and cutouts, then move on to Boolean operations, and finish with mesh cleanup and a sleek SubD effect. Let's dive in. Press numpad 1 for front view, then drag in the reference images. Make sure to check out the links in the description below. The cube measures 2 meters on each side. Obviously, the image is too big. I'll resize it to real-world scale. I'll install these add-ons. They'll make the modeling process easy peasy. So the first step before we would even get into modeling is to analyze the topology. The mesh is a tapered cylinder with a hole running through it and a threaded base at the bottom. It features a beautiful spiral pattern with 3 large axisymmetric baffles, each with 5 helical ports. From top down, the mesh looks like this part rotated 5 times radially, except for the threads, which I'll leave for last. I'll start with a cylinder as the base mesh and set vertex count to 5 times 5, or 25, so each copy will have 5 segments, giving it a moderate level of detail. I'll also switch caps type to triangle fan. Press Ctrl A and apply rotation and scale to update the mesh's transformation data. Press Ctrl R to add edge loops, but don't overdo it at this stage. Before scaling the vertices, press O to activate proportional editing. It's perfect for smooth transitions. Hide the base mesh, and I'll move on to creating the cutouts. I'll start with a cube and bevel the edges for the round corners. This part can also be made with a cube. The chamfer here is basically a change in the cutout thickness. Now that the cutouts are done, let's test the Boolean. Select the cutout meshes, then the base mesh, and press Ctrl numpad- for a Boolean difference. The cutouts are shown as bounding boxes, and I can still tweak the details in edit mode. Now select all the cutout meshes and press Ctrl-J to combine them. Next, I'll create the radial copies. I'll add an array modifier to the cutout, set the count to 5, and switch to Object Offset. Add an empty and set it as the offset object. When I rotate the empty, you might wonder why the copies aren't showing. It's because the pivot's off. The mesh rotates around its origin, marked by the yellow dot. I'll move it to the world axis center. The result's still off because I haven't updated the cutout's transformation data. I'll apply rotation and scale, and it'll work this time. Now that the cutouts are done, let's move on to the tricky part, the hollow effect. Stay with me. I'll add a solidify modifier to the base mesh and move it to the top of the stack. Hold Shift while fine-tuning to slow the changes and get better control. This area has some depth, so I'm going to apply the solidify modifier for real volume. Select a vertex, press Ctrl-L to select the outer part, then hit H to hide it for now. The fastest way to fill open caps is by using the Select Non-Manifold tool. After filling, switch to face mode. Right-click and choose Poke Faces to create radial triangle fans. I'll bevel this edge loop to smooth the transition here. Alt-H to unhide all. Let's move on to creating the top. I'll create the bore using a 25 vert cylinder to match the base mesh's vertex count. If you're not happy with the bore size, press Shift-Z while resizing to constrain changes to the XY axis only. And now the holes are created, looking pretty good. Before applying the modifiers, I'll add edge loops to match the cutout structure and further smooth the tapered part. If you find this video helpful so far, please don't forget to hit that like button and subscribe for more content like this. Your support really means a lot to me. Once we finish the base mesh, I'll duplicate it for later use, remove all modifiers, and hide the duplicate for now. I'll cut this part and rotate it radially to finish the rest. Hit K, then C to cut through the mesh. I'll use Lasso Select to quickly grab the desired vertices, then zoom in to deselect the unwanted ones. Press Ctrl-I to invert the selection, then delete the selected vertices. Next, copy the modifiers, select the target, then the source. Press Ctrl-L and choose Copy Modifiers. Enable Merge Vertices and reduce the distance to weld the seams. Also, enable First and Last Copies. Add a SubD modifier to check if the vertices are welded properly. Next, I'll clean up the extra verts, grab them all and merge by distance for a quick cleanup. Enable Auto Merge Vertices, then slide and merge the verts to keep the shape intact. I'll speed this up so it's not too boring. Verts cleaned up, now bevel the boundaries, set segments to 2, and shape to 1 to maintain the original form and tweak the width. This ensures the boundary lines are clean and pushes the verts that need tweaking to the surfaces. Don't worry about this line. I'll delete it after merging the copies. I'm going to make a cut here so the 2 triangles become quads. The Relax tool quickly smooths the verts while preserving the shape. I'll merge these vertices and simplify the topology here. There are 2 6-point poles here, but don't worry, they won't affect the final result. Now that the outer part is done, let's focus on the inner section. The rest follows the same process, so I'll skip it and leave it to you. Next, I'll fix the bumps. Add a Shrinkwrap modifier below SubD, set the copied mesh as the target, and apply a 2-level subdivision to it. The mesh looks a bit off because some vertices not on the surface are being pulled, causing distortion. I'll use a vertex group to control the area affected by this modifier. With these vertices selected, go to the Data panel and assign them to a vertex group. Then, set the Shrinkwrap modifier to use this group. The bumps are gone and the surface is smoother. I'll switch the viewport shading to vertical zebra lines to better visualize the Shrinkwrap modifier's effect, showing the difference in shading. You can also check the before and after effect in the car paint texture. To prep for SubD, select the sharp edges and set their bevel weight to 1. Add a bevel modifier above the SubD. Set method to weight, segments to 2, and adjust other parameters. Use the circle command to reshape it, and you'll end up with 20 vertices around the ring. To create the thread, add a bolt without head and set the division count to 20 to match the base mesh. Slide and merge these vertices, and we'll have the perfect muzzle brake mesh. I'll wrap up modeling with a normal check. Blue indicates correct normals. If you see red, press Shift-N to flip them. That's it for this video. Check out my topology playlist for deeper dives, and don't forget to like and subscribe for more Blender content. Thanks for watching, and see you in the next one.